Okay, good morning, everyone. Okay, how did the homework go? Please put your question on chat. Right, so I start by reminding you what are the main trig identities we've seen, and after that I will take any questions. What? Okay. So the trig identity we've seen last time were first the main identity, which is the Pythagorean, which tells me that regardless what the angle T is, we have that equal to 1, and that's the one of the most important trig identity you will use. And from this one, we can deduce that the cosine square, I can subtract the sine square, and the sine square is 1 minus the cosine square of t. Okay, so that's the relationship between the sine and cosine. And then we saw a relationship between the tangent and the secant. Who can remember this relationship? Who can remember the identity that related the tangent and the secant? Anyone?
Secant is equal to 1 plus tangent squared.
Exactly. That's another relationship that, again, it's a very useful one. Now, the other one we built up that also are important are, those are the identity. It means if you take the cosine of minus t is exactly the same as the cosine of t. It means cosine minus pi over 3 equal cosine pi over 3. Cosine minus pi over 4 equal the cosine of pi over 4. And then we did the same, something fairly similar to the sine. And we said the sine doesn't work this way. It was the minus sine t. And the way we figured this out for the last two is usually we have to go back to the unit circle. And sorry, I have to mute. There is noise here. If this is t, minus t is here. The cosines are the same because the cosine is the x coordinate, but the sine are definitely opposite to each other. So that's where those two are coming from. All right. Okay, so we're gonna go through some problems because you guys don't have anything, but we have to make sure you guys know how to do all those problems. So I will go through some problems from the homework and then we proceed with more trig identities today. Right. So true or false. So first I'm going to do a bunch of true or false questions and then I will proceed. So number one is true or false. True, you justify. False, you give me an example. Are those equal? True or false? Okay, I'm expecting answers. So the question is true or false? All right. False, you justify, and true, we justify. So if you say false, why it is false? Alex.
Because for the first one, you multiply t by 3 and then you apply sine, whereas the second one, you times it times 3 after you apply sine.
Exactly. So that is absolutely a false statement. So this is absolutely a false statement. Okay, so let's see what's happening in the first, what's happening in the second. As your classmate said, here you're taking the angle, multiplied it by 3, then you take the sine. However, here you take the sine and then you multiply by 3. So let's do that as an example. So to tell me it's false, you have to give me a value of t's that would make this false. So for example, suppose we're going to evaluate sine 3t. So we're going to evaluate this at, let us say, an easy number. Let us say at t equal pi over 2. And then I'm going to evaluate here 3 sine t at t equal pi over 2. And we see the difference in the evaluation, so you know why this is false. When I evaluate this, what do? I take the sine 3 at t equal pi over 2, and I multiply by that, which will give me the sine of 3 pi over 2. So I'm multiplying the t by 3, and then I take the sine. So sine of 3 pi over 2, if we go to the unit circle, 3 pi over 2 is right there. The sine is the x-coordinate, which is -1. However, when I take 3 sine t, it's 3. You multiply it by the sine of pi over 2. So it's a very different operation. It's 3 times the sine of pi over 2. Pi over 2 is here. The sine is 1, which is equal to 3. They are absolutely different. So you cannot pull the 3 out. So here the t is multiplied by 3, then you take the sine. Here you take the sine, and then you multiply by 3. So it's an absolutely a false statement. So we have to be very careful with that. We cannot just take the 3 out. It's absolutely wrong. All right. Again, I'm working first with true and false, and then we a bunch of them. So part 2 is, for example, number 4. Okay, and the question is, are those equal? Secant t times the sine of t, is this equal to tangent t? True or false? True, you justify. False, you give me an example to show me it's false. True, it means no matter what t is, those will be the same. All right, back to you, true or false. Each one of you should be able to participate. Okay, anybody else? Anybody else? Is this a true statement? Okay, I will pick one of you. Tim da Silva. Do you think it's true or false? Wouldn't be false because secant is 1 over cosine. And tangent is sine over cosine. All right, so let me go with Jaden's argument. Secant, and then we decide whether it's true or false. Okay, so what's secant? Times the sine of t. So as your classmate said, the secant is 1 over the cosine times the sine. But this is equal to what? Okay, 1 over cosine times sine. This is actually equal to what? So if I give you, for example, a half times 3, this is basically what? Back to you. How do you multiply those fractions? It's basically 1 times 3 divided by 2. It's 3/2. What I'm trying to get to you. What's 1 over cosine times sine? It's actually exactly sine over cosine. Okay, you multiply the numerator, so you can think of this as divided by 1. Multiply the numerator, you get sine, you get. So true or false, it's absolutely a true statement. Why it is true? Because that's why it is true, because this is exactly the tangent of t. All right, so we have really to do a little bit of math. So this is absolutely a true statement. All right, I keep along the same lines. And as I said, I want all of you to be part of it. So I'm still with the true and false question. And I will, let's see which one I want. I mean, I want all the problems I've assigned. So 38. It doesn't have anything to do with sine and cosine, but it's a very typical mistake the student do. Again, true or false quickly. Basically, can I break the denominator? True or false? I want a quick answer. False. Anybody else? Absolutely, absolutely, absolutely false. We can never break the denominator. I mean, we cannot ever break the denominator. We can break the numerator. Now, how do you convince me it is false? I mean, we should all know that. Let's just take x to be, I don't know, let's take x to be 1. So 1 over 2 plus x, it's 1 over 3. However, a half plus 1 over x is a half plus 1, which is absolutely 3/2. So absolutely, absolutely false statement, right? Okay, now we're back to sine and cosine, number 41. No, 41, we just did it. So, but let me make sure if you guys get it. Sine 2x equal to sine x. True or false? Okay, quickly, can I take the 2 out? Okay, true or false? I don't know which question you guys are answering. So I see false. I don't know which one. I want this one. True or false? Kishan Williams, I think. True or false? Yeah. Kishan William, are you with me?
Yeah.
True or false?
False.
Because. What's the difference between those two? What are we doing here? We start with the x. First, you multiply the angle by 2, then we take its sine. Here, we take the sine, then we multiply by 2. So again, we can take example, right? Let me take, I don't know why I'm taking pi over 2. I don't have that. Then the sine 2x is, you take the 2 and you multiply it by pi over 2. It means the sine of pi. Now, what's the sine of pi? If I go to my unit circle, this is pi. The sine is dy coordinate, which is 0. However, when I take 2 times the sine of x, I'm taking 2 and I multiply it by the sine of pi over 2. Very different operation, which is 2 times. Pi over 2 is up here. The sine is 1, which is equal to 2. So absolutely different. We cannot really remove the 2. All right, now number 46 on your true and false. I will put it out and you guys will answer the question. 46 is the following. Okay. So they tell me that sine squared theta minus 1 over cosine theta. And the question, is this equal to minus cosine theta? So this is a bit harder, but we should be able, we will take it, we will try to do it. So the question is true and false, true justify, false justify. So basically they are expressing this in terms of cosine. Are those equal to one another? So I'll give you a minute to interact with the problem, each one of you, please, and then tell me what you come up with. You will need the trig identity, the Pythagorean theorem, or the main trig identities to proceed in this problem. Okay, Jacob tells me false. Anybody else? Anybody else? Agree, disagree? False, math, everybody, uh-oh. So now I have false and I have true. So let's work it out. Let's work it out, because this is not this is unlike the sine 2x to sine x, because once you look at it, I want you by now to know that they are not the same. This one is harder because we don't have really a feeling for it. So the way we're going to do is the following. So they are expressing this whole in terms of cosine. So what we're going to do is express this in terms of cosine and see if we get minus cosine. So by Pythagorean theorem, we know that the sine square is 1 minus the cosine square. So we're going to substitute like what we did last time. So instead of sine square, I'm going to put 1 minus the cosine square minus 1. I'm going to substitute verbatim, divided by the cosine. And I'm going to ask myself, so I'm substituting instead of sine square, because those are the same, I'm really putting that. I'm asking myself, do I get minus cosine? All right, 1 minus 1, they go, I will have minus that over the cosine. But this is equal to what? Let us remember, what's cosine square? Cosine square is cosine theta to the power 2 over the cosine of theta. So this is going to give me what? So this is minus cosine, if you want, times the cosine divided by the cosine. Now I can simplify this and this, which will lead me to minus cosine theta. So, of course, now, is it true or false? What do you think? Is it true or false? It means, is this equal to that? We actually verified it, that if I start here, I get exactly minus cosine. So we get exactly. So this is minus 1 over the cosine of theta is actually equal to that. And the only way we were able to do it is by showing. So this is absolutely a true statement. Okay. So in this problem, we had to do the math to be able to reach minus cosine theta. Okay. So it's true, absolutely true statement. Yeah, absolutely true statement. So be very careful. Sine square. So let me add the following question now to this. True or false? Okay, true or false? Sine square theta minus 1. Is this equal to the cosine square theta? True or false? Because I want you to be able to understand where is the mistake coming from. Is this true? Remember, what's the true statement? What do we have for cosine square? What's the relationship between cosine square and the sine? What's the cosine square? It's 1 minus the sine square. So be very, very careful. The cosine square is 1 minus the sine of square. So sine square minus theta is not the cosine square, because the cosine square is 1 minus, but that's sine square minus. So this is absolutely, I'm sorry, that's a false statement. That's a false statement. Okay, because the cosine square is 1 minus the sine, not the sine square minus 1. So that's really what happened. There is a negative sign, absolutely. That's a negative sign. That's why you guys got messed up and you told me it's false. So cosine square theta, so sine square theta minus 1 is actually equal 1 minus cosine square theta minus 1. It's minus cosine square theta. So the minus plays a role. Absolutely, it plays a role. Okay. All right. So now, these are the true false questions. Those are actually very good questions. Now we're going to keep doing, practice more and more how to prove simple trigonometric identities. So the one I would like to do is the following. Which one I want to do? Again, from the homework I'm going to assign, and the question is, so this is number 9 from the homework, and the question is, simplify the expression, and your answer should involve only sine and cosine. So I'm going to give you an expression, and the answer should only involve sine and cosine. So what do we mean by that? You guys, those are homework. You should have done those. Okay, so this is an expression that involves tangent and cosine and sine. The question is, express it in terms of sine and cosine only. Somehow they wanted to get rid of the tangent by substituting it by its value and see what do we get. Okay, so I will do the first one, then I will give you another one. You guys work on it together. So they don't want tangent. The question is clear here. So how can I substitute tangent by its value? What's tangent? I'm going to substitute here. Sine over cosine times cosine. I am substituting verbatim. Okay, substitute tangent by its value minus the sine of t divided by the tangent is the sine over the cosine. So we're going to substitute tangent t by its value. That's what I am doing. And now I want to simplify. How can I simplify this expression? All right, how can I simplify this? This should give me what? I want answers on chat. How can I simplify this first one? Is it easy or hard?
You can just get rid of the cosine.
Absolutely, I can absolutely get rid of the cosine because this is like, you know, basic algebra. That's sine of t times, so this could be rewritten sine of t times cosine of t over the cosine of t. So that's a common factor of the numerator and denominator, so this could be simplified. So this really gives me the sine of t only. How about that? How about this term here? This is my denominator, okay? And let us remember the property of fraction. This is gonna give me what? That's the sine of t multiplied by the reciprocal, cosine over sine. Okay? So the problem is really here to kind of do algebra and trig at the same time. Now, as I did before, this sign and this sign really simplify, and what I'm left with is minus the cosine of t. Okay, so express in terms of sine and cosine. We're done. We express it in terms of sine and cosine. Question as I move on. Okay. Right. I'm going to assign again some of the problems for next time because I insist that you guys do them. Now I'm going to do again the same type of problems, and it's problem from the worksheet. So the worksheet I gave to you. I'm going to ask you to do the following. Okay, verify the following identity. Verify the following identity. So I'm going to give you statements that are true, and you have to tell me why they are true. Okay, so I start with the first one. Sine t over tangent t equal to cosine. And the only thing I want you to do is verify that this is a true statement. It means it is true. The question to you is why it is true statement. Okay, so how can we deal with a statement like that? Guys say, you know, they want cosine here. So somehow I want to get rid of tangent. Tangent is the sine over the cosine. And now I do my algebra. One fraction So this is the sine times the cosine over the sine. And now what I did a minute before, this gives me the cosine. So my statement is correct. So when I ask you verify the following identity, it means I am giving it to you, the identity, but I want you to verify it, just to tell me that it is true. So we have to go from here to here, ask ourselves, okay, they don't want tangent here. So let me get rid of it by substituting the tangent by its value. Another problem along this line, but this time I want you to do it yourself. So this is from the worksheet I put for you. Another one is the following. Verify the identity. 1 minus the sine times 1 plus the sine of t. I want you to verify that this is true. Okay. So the way we do it, we start from this complicated one. We try to simplify it, and we try to get to cosine square. Right, so I'll give you a minute or two to a little bit interact with it. How shall I start from here to get here? Ideas. Start working on it, and then I'm going to ask each one of you, what are you doing? What is going on? We're going to start from the left and go to the right. It's true. I know it's true. I'm giving it to you. I'm telling you this is it true. What I'm asking you is to verify it is true. I mean, to really actually convince me that it is true. I know it's true. I'm giving it to you. You have to tell me why it is true. Any idea? How do you think I'm going to do that? Anybody would like to lead? Exactly. We're going to distribute. 1 times 1 plus sine t. So I am distributing. Then minus sine t minus plus minus sine times sine square of t. Okay, so what we did is distribute and hoping to get to the cosine. Plus sine minus sine, of course they disappear. I will have 1 minus the sine square of t. But I want to get to cosine square. So what shall I get? Now, either you remember that the cosine is exactly the 1 minus sine. So if you remember that the Pythagorean tells me that the cosine square plus the sine square, but you have to remember it correctly, equal to 1. It means that the cosine square is actually 1 minus the sine square. So remember it correctly. So it's going to give me 1 minus sine square, which is the cosine square. My identity is correct. So if I give you an identity, a simple one, of course, those are simple ones, and I ask you, okay, show that this is equal to that, you start from the left and you kind of work your way out. You distribute, you find a common denominator, and you try to get to the right one. I finish with the following. It's again on the worksheet. And it's a little bit harder, but not much harder. Okay, I have this expression. Okay, it was too complicated a little bit. And I want you to convince me. So that's a true identity. I want you to convince me this is the same thing as that. Okay, I want you to convince me. So this is a true identity. I want you to convince me that those are equal. It means you have to start from the left, somehow do something logical, and then get to here. So I start from the left. And I want to get here. All right. Ideas. How do you think I can proceed?
You'd have to find a common denominator.
Absolutely correct. Common denominator. Now, what's the common denominator here? Now, I know that you have cosine t, sine t. It seems like complicated, but believe me, it's like regular denominator. That's regular denominator in the following sense. If I have a half plus a third, if I have numbers, the common denominator is the product. It's 2 times 3. Okay, so to find the common denominator, it's just you're going to multiply, and then you say, I multiply this by 3, and I multiply this by 2. And then I combine the numerator. Okay. This is the same thing, but instead of having numbers like 2 and 3, I have a little bit more abstract. This is the denominator, cosine and sine. So the common denominator here, we're going to find the common denominator, is the product multiplied by the sine. You just multiply the two. So that's the common denominator. And now we're going to find, that's my common denominator. Now let us find a common, so put everything under the same common denominator. If this is cosine t times the sine of t, means I have to multiply this by the sine of t plus. That's the common denominator. It's the sine times the cosine. So I have to multiply the top by cosine. Okay. Now, the goal of the common denominator is to be able to combine the numerator. So now I'm going to combine the numerator. So that's cosine, and that's the sine, and I'm going to combine sine times sine, and that's the notation. It means sine squared plus cosine squared. Now, I have to keep my eye here. I have to get you here. So am I done? What do you think? Can I get here from this expression? So the question is, my goal is to convince you that this term is the same as that. Do you think I am done? Do you think I convinced you or not yet? How can I finish?
Isn't sine squared t plus cosine squared t an identity?
Yeah, it's
right?
Y
That
equals
equals
Y.
1.
Exactly. Right. I'm done. I'm done. Done. It means if you take this term, no matter what t is, it's exactly the same thing as 1 over cosine t times c. So it's exactly the same. Okay, so we start from the left, we manipulate a little bit, and then we use what we've learned. And the whole idea of those problems is really kind of getting used to this identity and use it in a problem. Okay, question before I go on. Now, in the worksheet, there's still one problem, which is D, but I don't want to do it because if I do it, I really will not be helping you. I want you to do it. I insist that each one of you do it for Monday, and you will discuss it. Okay, it's again the idea of a common denominator, but I want you to sit down and do it yourself and see if you can get it. And that's so you learn those ideas. So today we're going to keep working with those identities. And as I said, the trig identity is the important one. Now we're going to see other identities. Those you don't have to memorize. The one that I want you to memorize is the trig identity, but we have to know what they are and how to work with them. So the new identity is something called double angle formula. It's still the same section. Okay. First, let's get one thing straight again, I've talked about it and I'm gonna, again, if you have the sine of 2t, it's not 2 times sine t. Okay, so we cannot pull the 2 out. Okay, the double angle formula is an identity, which express the sine of 2t in terms of sine and cosine. So we're not gonna prove it, but we're gonna a little bit work with it. Okay, so double angle formula tells me the following, that the sine of 2t, if you double the angle, doubling the angle, it's equal to 2 times the sine of t times the cosine of t. So you multiply the sine by, so it's definitely not 2 sine t, it's 2 times the sine times cosine. Okay, so that's really what this double angle formula tells me, that if you double the angle, it's twice the sine times cosine. And there is another one for the cosine. So if you double the angle of cosine 2t, again, you cannot pull. So cosine 2t is definitely not 2 times the cosine of t. Okay, you cannot really pull it out. But there is a formula for it. I hate to give you lots of formula, but I don't have any choice for those. It's the cosine square of t minus the sine square of t. Okay. Now we're going to do exercises, and the goal of those exercises is really to practice those formulas as simple as that. So how we use them. So let me start with the following problem. I'm going to do 2 problems here. Okay, problem number 1 is the exercise problems. Okay. Suppose I give you an angle. So you're given that T is an angle whose sine is 1/4, for example. And my angle is between pi over 2 and pi. Okay. My question to you is the following. I want you to find cosine of t, the sine of 2t, cosine of 2t, and the tangent of 2t. And the idea here is without finding t. What do I mean by that? If I give you the sine to be 1/4, I know that t is arc sine of 1/4. The idea of this problem is that I want this to be done without finding the angle by using the trig identities. That's really the goal of this problem. We're going to use all the trig identities to find the cosine, the sine of 2t, the cosine of 2t, and the tangent of 2t. All right? So step number 1, I want the cosine. And this is something I did last time. If I know the sine, how can I find the cosine? First, I look at the angle. We have to be precise, so let us pay attention. Let us note. So first, I'm going to find the cosine. Okay. Now, note that my t is given to be in quadrant 2. It means the cosine, since I'm in second quadrant, has to be negative. Okay, so it depends which quadrant I am. Now I need to find the cosine. I know the sine, I need to find the cosine. Now we did that last time. What's the relationship between the sine and cosine using the trig identities? We know that cosine square, and you have to be very careful, it's 1 minus the sine square. Okay, now this is not actually hard. This is equal to 1 minus. We know what the sine is. The sine is 1/4. So this is 1/4 square. It means 1 minus 1/4 times 1/4 is 1/16. Now common denominator of 16 will give me 16 minus 1/16. It's 15/16. So that's the cosine square of t. So that is that. It means The cosine square, it means if you take the cosine and you square it, you get 15 over 16. So this will give me the cosine. So the goal, as I said, for those problems is actually to practice the identities. So this will give me that the cosine can be either the positive square root or the negative square root. Okay. Now, this I can simplify. This will become the square root of 15 over square root of 16. It means square root of 15 over 4. And square root of 15, I cannot do anything. I just keep it. And this one will give me minus the square root of 15 over 4. So now I know the sign. So I am right here. I am in a circle. That's really my picture here. My angle is in the second quadrant and its sine is 1 over 4. So that's really the sine. So I know the sine. What I did is actually find the cosine, which is I know it's negative. So this is right here is 1 over 4. So the cosine of t, since t in quadrant 2, the cosine is negative, is equal to that. So this gives me the cosine. So I knew the sine, now I have the cosine. Now they want me to find sine 2t. So it means if I double this angle, which is gonna put me, I don't know, somewhere here, I guess. If I double this angle, what's gonna be the sine? So sine 2t. At this stage, I use my identity. If I double the angle, what's the sine of it? It's 2 times the sine of t cosine of t. That's how I'm using the double angle formula. And this will give me what? 2 times. What's the sine of t? The sine of t is given to me to be 1 over 4. What's the cosine? The cosine, I found it. And the rest is algebra. So this will give me, how do we multiply fraction? We multiply across the numerator, which will leave me with that. And over, we multiply the denominator across, which is going to give me the square root of 16. Now, there is one thing we can do, because the square root of 16 is 2 times 8. I can simplify by 2 because it's a common factor, numerator, denominator, and it will leave me with that. That's the sine of 2t. Okay, so that's how we are used. So if I know the sine of t and cosine of t, I can find the sine of double the angle of 2t without having to find the angle. Because sometimes we know really exact value, and this is really the exact possible value. Now I can find the cosine of 2t. The cosine of 2t, the formula I gave you is the cosine square of t minus the sine square. Now I substitute everything by its value. It means the cosine of t squared, I rewrite this, minus the sine of t squared. Be careful, that's a minus, not a plus sign. Now it is equal to, what's the cosine? Over 8 squared. Minus the sine is 1 over 4 squared. Okay, now it is equal to what? If I multiply this by itself, I will get, so it's a square root of 15 over 8 times the square root of 15 over 8. Minus minus is a plus, so I will have 15 over 8 times 8, which give me 64. Okay, and this one would give me 1 over 4 times 1 over 4 is 1 over 60. Now the last step we can do is common denominator. Common denominator here. Now 64 divides 16. So the common denominator will be 64, and this would give me 15 over 64 minus. If I take 16 and multiply it by 4, remember, 64 is 16 times 4. So I have to multiply this by 4. So this would give me 11 over 64. So what we're doing is really basically applying those identities. So we know how to apply them. So now I have the sine and I have cosine 2t and sine 2t. Now what's the tangent of 2t? Well, I have a lot to scratch. What's the tangent? Is this now hard or easy? What's the tangent? The tangent is the sine of 2t divided by the cosine of 2t. Whatever it is the sine over the cosine. All right, this is equal to. Now I know the sine, we evaluate it to be that. I will evaluate the cosine, which is 11 over 64. Another question is simplify. And in those problems, I will ask you for the exact value. It means I don't want decimal. I really want fraction. So now I have one fraction divided by another. Let's do the math. It's divided by 8 times 64 divided by 11. And now what do we get from here? So we multiply across the numerator and we multiply across the denominator. 8 times 11. And the last step would be 64 is 8 times 8. So I will have 8 times 8 over 8 times 11. Now 8 is a common factor. I can simplify it, and my last answer would be that. Tangent 2t. Okay, so once you hit the tangent is never problematic. It's the sine of whatever angle you have. You have tangent 2t, it's the sine of 2t over the cosine of 2t. And then we have the answers. Questions? All right. Another problem along those lines that usually I do a lot in calculus 2 actually is the following. It's very much the same type of problem, but I'm putting triangle into the picture. So this is my problem. Okay. And we should be able to do it, all of you, all of us. So the question is I'm going to give you a triangle, and the question is use the triangle to express each of the quantity below in terms, so each of the quantities, I'm going to give you a bunch of quantities, each of the quantities in terms of x. You will see what I'm talking about when I draw the triangle, okay? So suppose I have this right triangle. Okay, this is my triangle. And this is my x, and this is a 2. And this is an angle. I'm going to call it T. Okay, this is a right triangle. So I'm going to give you a bunch of quantities, and I want you to express in terms of x. Okay, so the first easy one. What's the sine of t? Just do quickly. What's the sine of t? That's your triangle. What's the sine of t using the triangle? Are you guys with me? Okay.
It would be x over 2.
It's x over 2. That's the idea. Okay, it's the opposite over the hypotenuse. That's really what I want. Now, what's the cosine of t? I give you a minute to figure it out, and then one of you will have to answer me. Now you know what, we're setting the stage. Now you guys give me the cosine of t. And one of you will be picked. So those who find it, put it on chat, and then we proceed. Okay. All right, so it's adjacent over hypotenuse. That's correct. So you have to compute the adjacent over the hypotenuse. So he's right, adjacent over hypotenuse, because I'm working in a right triangle. Very good. I want it in terms of x. So this is equal to what? The hypotenuse is 2. I don't have an issue with that. What's the adjacent? Means that's the adjacent. How can you compute the adjacent? Easy or hard? So this is your right triangle. I'm in a right triangle, and I know I want this side. How shall I compute this side?
Can't we use the Pythagorean theorem?
Exactly. Use it for me. Go ahead.
So we know that x squared plus, well, we know that a squared plus x squared equals 2
Okay, but I
squared.
want you to use the letters here. So let me call this A. All right?
Yeah.
Okay. Use the letters here.
So we know that x squared plus a squared equals 4.
Which one I
Right.
want? Yes, you're absolutely correct. Keep going.
So, I mean, we know that a and x aren't equal. So I could say that a equals 2, but I
Ooh,
don't think that's the case because
no, you were on the right track. Why did you stop? This is correct, correct? That's Pythagorean theorem. I want A. So how can I
oh,
get?
sorry. We have to, wouldn't it be rad 2? A would be radical 2, right?
No, listen, watch, careful what I'm doing. A squared is 4 minus x squared. Am I correct?
Yes.
So A is what? A is what?
So A wouldn't be rad 2?
No. A would be the square root of this whole thing.
Oh, okay.
Got it? I mean, everybody. I'm talking to everybody, basically. Are you with me?
Yeah.
So that's the A. Exactly. So it's going to be the square root of 4 minus x squared. Very typical problem that I usually do in calculus 2. Are you with me? That's what, it's not the radical 2. I don't know. There is an x in here. And I know that the x is bothering you, but that's fine. We have to learn how to do things.
Okay.
It's going to be that. That's the cosine. So what's the adjacent? I did not give you the adjacent, so you have to go after it. All right. Now, what's the tangent? Now, at this stage, I feel comfortable asking you anything I want. What's the tangent of t? Some of you, I didn't finish grading your exam. Some of you are confused, not confusing, are not memorizing those correctly. The tangent is what? Two things, either sine over cosine, in general, that's the exact definition. In a right triangle, it's also opposite over adjacent. Okay, so you can either use sine over cosine, or you can use, if you are in a right triangle, to be the opposite over the adjacent. This is in a right triangle, which is equal to, the opposite is x, the adjacent, the square root of 4 minus x squared. Okay, so I'm working in a triangle in this particular problem. All right, what else can I ask you? Okay, what's the secant? That's a good review of all those functions. What's the secant? What's the definition of secant? Quickly.
Hypotenuse over adjacent, right? Or 1 over
cosine.
yeah,
I don't care
cosine.
which one. I don't care which one you memorize, but this works in general. So we don't have to be in a right triangle. Always this is true. Okay, so this is equal to, now I have it. All right, so you can either flip this hypotenuse over adjacent. That's really what it is. So, or you can do the math. This is the square root of 4 minus x squared over 2, which is 1 times 2 over the square root of 4 minus x squared, which is hypotenuse over adjacent. Minus x squared. Now, of course, I want sine of 2t, because we're talking about the double angle formula, and that's why I'm going to bring it up here. Sine of 2t. Now I have no idea what sine of 2t is. I cannot really use this anymore. Okay, why can't we just do, I will get back to your question, Kishan, in a second, all right? Why can't we do tangent t plus 1? For which one? Kishan, can you speak? Do you have a mic, a microphone?
Yeah.
Okay, explain to me your question.
I was asking that about the secant one.
Okay, secant. Okay, it's a good question. It's a good question. All right. Let me remind you what the secant is. It's not secant theta. Watch carefully. It's a very good question. Secant square theta is 1 plus tangent square theta. It's not secant theta is 1 plus tangent. This is not correct. It's the secant square, which 1 plus tangent square. And now let me make myself a little bit more clear, because that's really the relationship. Now, you could tell me, maybe, I want to make myself clear that if secant square is this, then secant is the square root, right? Kishan, are you with me?
Yeah.
Okay, now can I break the square root if I have a sum? We've talked about that last time. It means, is this equal to that? Yes or not?
No.
What?
No.
No. So this is not 1 plus tangent. So what you have is secant square is 1 plus tangent square. So if you want to use it, it's all right, but you have to be careful. It's the secant square, which is 1 plus tangent square, not the secant. So it's not 1 plus tangent. It's the square of that, which is 1 plus the tangent of t squared. And the reason is that you cannot split the square root. So this is not that.
Okay.
Right? Okay. So now sine 2t. Sine 2t is, now I have to use the double angle formula times the cosine of t. So once I find the sine, I can use double angle formula, which will give me sine of t. I know it, it's x over 2. Cosine of t is the adjacent over 2. Okay, so once I find the sine of t, I can now use, I want sine 2t, now that I can use my double angle formula. And this will be equal to multiply, we multiply across in the numerator, multiply across in the denominator. Okay. Now 2 is a common factor, numerator, denominator, I can, and I will be left with x, the square root of 4 minus x squared divided by 2. Okay, so that's, as I said, the trig identity is something we should be aware of it, and the problems are made up so we can practice them. That's really how we are making up those problems, so we can actually practice them. Questions before I move on? All right. Now, what other trig identity we care about? So far we saw the basic one, the one that I care about the most, that I keep repeating, I care about the most, is the main trig identities, and the one relating to secant and tangent. Double angle formula is, you will be given to it, so I will make you use it, but I will give you the formula because you guys will not remember it a lot, but that's what it says. So it's a useful formula, but you don't have to memorize it. However, you have to memorize the other one. Now, there is another property of sine and cosine, another formula. I will first ask you questions, and then we will proceed. So sum and difference. I think it's so sum and difference. Sum and difference of sine and cosine. Okay. All right. One fairly common mistake we do, it's a very natural mistake, but we have to address it, is the following. Before that, there is a notation that we should know. This is, you know it, I've been using it a lot, that's theta. There is another Greek letter that the book uses, and it's used a lot. You guys know what we pronounce this? Anybody? Okay, this Greek letter is used a lot to represent angle. It's not omega, no, it's phi. Okay, it's phi. All right, so omega, that's omega. Okay, so it's a lot of time it's set phi. Okay, so that's theta and phi. All right, so the question is the following. Suppose I have sine, and inside it I have two angles. Now I hate to use theta and phi, but I have to prepare you because that's the notation the book uses. So I have the sum, two angles. And the question is, can I break the sine? It means, is this, can I break it? We would love to, but is it correct? Okay, so we always start with what's not right. So in the first, when I talk about double angle, my first question was, is the sine of 2 theta is twice the sine of theta? And the answer was no. Now my question is, can we break the sine? It means if you have two angles here and you add them, can you break this? What do you think? No, absolutely no. We cannot break it. Okay? Our natural tendency is to break it, but it's wrong. So let us think of an example. Who can give me an example? I'll give you a minute to replay with it. Of two angles. So I want you to give me an angle theta, whatever angle you think, and I want you to give me an example of an angle phi, so that this equality fail. So who can give me example of angle theta and phi that will make this equality fail? I give you a minute to think about it a little bit. Just play with angle and play with easy angles. So don't make life hard. Play with angle that you know how to work with, like pi over 2, pi. You know, work with easy angles. If I ever find something, let me know. The first crucial that we cannot break it. And now example, and then the question is, what can we do when we have that? Okay, theta 90 Kisha, for which one? I need two of them. Which one you want? Theta 45. So he's working with degree. I will keep going. And we want 60. Oh, okay, we will do that. All right, I want it easier one. So let me evaluate each one of them. So we're gonna first evaluate sine of 45 plus 60. All right, 45 plus 50 is, so it's gonna give me 105. Now, I don't know what's sine of 105. I'm gonna pick up my calculator and evaluate it. That's why I wanted easier angle. So usually my calculator is in degree mode, in radian mode, so I have to switch. And sine 105. 105. And I'm getting 0.965. 9, okay? Now, anybody who can think of easier angle, please be my guest. Now I want to evaluate sine of 45 plus the sine of 60, okay? And hopefully we won't get the same answer. 45 is one of the angles that we should know. It's the square root of 2 over 2. 60 is the square root of 3 over 2. So now I need to evaluate that. So this is going to give me, and I'm going to just evaluate this on my calculator because the numbers are not nice here, divided by 2 plus the square root of 3 divided by 2. I'm getting 1.573. Absolutely different from another. Okay. Now we could have worked with easier angles, like I could have worked with pi and pi over 2, which are usually easier to work with. I don't even need my calculator for that. So, but the important idea is I cannot break it. Absolutely, we cannot break it. So in trig, what we are interested in is the following. If I know the sine of theta and I know the sine of phi, what's the relationship between sine of the sum of the angle versus the sine and of each one of them separately? And here is the formula that I don't memorize them. We will never memorize those, but I will write them up. So this is the trig identity that's related to the sum of angles. I will write it and then I will work with it. So sine of theta plus phi is equal to, in terms of the sine of theta, is the sine of theta, the cosine of phi, okay? Plus cosine theta times the sine of phi. And if I have a minus, again, I cannot break it. So the whole idea that we cannot break if we have a sum. It's the same thing, but it's a minus instead of a plus. Minus cosine theta, the sine of phi. Okay, and there are very similar identity for the cosine, but I will only work with this one, and next time I'll work with the cosine. So we're going to practice this a little bit. One example is very practical. I mean, it's going to be with numbers. Another one is a bit more abstract. So the first one is just to basically how to work with that. So, question or problem? Okay. Find the exact value. The exact value, it means if the answer involves square root, I want you to keep it. The exact value of sine of 75 degrees. So this is we actually practicing this using the following fact. The fact that 75, I can write it as 45 plus 30. Okay. So the goal of this problem, as I said, is really to learn how to use this formula. That's really why we do those type of problems. All right, so what do they mean by that? What do they mean by that? So what's the sine of 75? Okay, so 75 is 45 plus 30. I want the exact value. It means I don't want to pick my calculator and plug in 75. I want the exact value. All right, this is equal to 1. And now let's see how we're using this identity. So this is play the role of, I can think of this as my theta, and I can think of that as the phi. So I have theta plus phi. And what does this formula tell me? This is equal to the sine of theta. Theta is 45. Okay, times the cosine of phi, which is 30. Plus, okay, plus what? The cosine of theta. Theta is 45 times the sine of phi, which is my phi is 30. Okay, that's really how we applying those. And now we want the exact value. It means basically I don't want you to pick up your calculator and do any of this. We're gonna do it exactly. And now what do we mean exactly? Let us remember. What's the exact value of sine 45? Who remembers the exact value? Always remember your unit circle. And when we took those angles on the unit circle at the beginning of the semester, those. Okay, what's the exact value of sine 45? Who will remember that? Put it on chat if you don't want to talk. What's the exact value of the sine squared 45? Yes, 45 is pi over 4. What's the sine of it? It's the square root of 2 over 2. That's the sine of 45 is the square root of 2 over 2 times. What's the cosine of 30? What's the exact value of cosine of 30? So remember, if you guys go to your unit circle, this is the square root of 2 over 2, square root of 2 over 2. That's the 30. It was square root of 3 over 2, 1/2. It means the cosine is the square root of 3 over 2. Plus, cosine of 45 is also the square root of 2 over 2 times the sine of 30 is 1/2. Okay, so that's the unit circle we're using. So finally, what do I get? We're going to simplify a little bit. So this is, I'm really getting the exact value here. Now, okay, what do I get? And I want to keep the square root. I'm not really touching them unless I can simplify them. So here we multiply over 4 plus we multiply across the numerator, multiply across the denominator, we get 4. So finally, I will get over 4 square root of 2 times square root of 3 plus the square root of 2. And now square root of 2 times the square root of 3. Because I have a multiplication here, I can combine under it. The square root of 6. If I had a sum, I cannot do anything. If I have a product, then I can do that. So this would give me this. End of the problem. When I ask for the exact value, that's really what I mean by the exact value. Nothing more, nothing less. Now, so the goal, as I said a million times by now, is to be aware of those properties, to know how to use them, because they will come up with you, but you don't have really to memorize them. But we should be aware that we cannot break the sum, and that's the relationship between sine of the sum and the sine and cosine of the angle inside. So I finish with the following problem. I don't know if it would be a little bit hard, but not too hard. So I want you to derive, let me write it down here. Okay. I want you to do the following. Use this identity. I want you to use this identity to derive the following. Let's see, I have it. Okay, to derive the following. Sine 2 theta equal 2 sine theta cosine theta. Okay. So that's the double angle formula. Now, as a nice exercise, how can I use this property to derive this one? So I said it's a little bit harder, but not too hard. Anybody has any hint? Before I forget, I have something I would like to share after lecture before class, if it is, if you don't mind. Oh, okay. No, I don't mind. All right.
Did you want like the formula or?
No, I want to be able to come up with that. I mean, how can I use this to show that? I know it's hard. I told you that. Okay. One way you can do it, we say sine 2 theta is that. Am I correct here? Is this correct? 2 theta is theta plus theta. Now I am done. How can I apply this? That's sine theta. So this is playing the role of phi here, what I did a minute before. Cosine theta plus cosine theta sine theta. Now I combine them to sine theta cosine theta. Okay, so I use this property to convince you to basically derive this one. I'm deriving the double angle formula from the sum formula. Okay. Right. So I stop at this stage. Before I let Jacob, please stay in. Jacob have something to tell us. I don't know what, he's surprising me. But remember, you have a quiz. If you don't remember, you have a quiz on Monday. Okay, so please do the homework, go over the lecture and ask questions, and your quiz is on Monday. Jacob, please, you can take the stage. What is it you want to tell us?
Hello, can you guys hear me?
I can hear you, yeah.
Hi, I just wanted to take a second to tell everybody that I don't know if everybody is aware about what's going on at the Westville campus or the changes that are about to go into effect as far as what's going to affect us as students, whether you're a new student or a junior, sophomore or anything, but there's about to be changes put into place where a lot of your classes that you either need to A, complete your degree with, or B, even start your degree is going to be heading over to the Hammond campus. I mean, not the Hammond campus, and they haven't had a lot of publicity on this, but if anybody goes to check to see for registering for classes, you'll realize that what the changes happened. So the student body, I have a lot of contacts as far as the student body goes, and as far as upper administration goes too. They put together a petition. So if anybody would like to sign the petition to try to keep classes at the Westville campus and not at the Hammond campus, because I know it affects a lot of us, and as far as traveling goes and everything like that, if you want to, you can put your email, your PNW email in the chat, and then I'll forward this email to you, which has the petition in it, as well as a message from the student body, one of the student body leaders. That's all I had to say.
Okay, I'll give you a minute to put your emails or whatever, get in touch with Jacob. So I'll give you a minute to do that. Okay.
If anybody doesn't want to directly send me in a message, if you think that's weird, I'm going to put my PNW email in the chat. Or if anybody's busy or anything, you can just copy my.
Yeah, Jacob, they left the room, so I don't think they know what they are. They left. So I don't think
Oh,
they
okay.
can do
That's fine.
anything.
I appreciate it.
Oh, sure, no problem. No problem. Good luck.
All right, thanks. Bye.
Bye. Anybody has any questions?